research group, standing for Knowledge Discovery and Intelligent Systems. His main research interests are the application of data mining, learning analytics, and artificial intelligence techniques to educational data, environments, and domains. He has a vast and high-quality academic work, including, between others, 50 papers published in journals with an impact factor, and some of them are important educational data mining surveys or review. He was also the co-editor of several special issues and 2 books regarding this matter, and he was also a founding officer of the International Educational Data Mining Society, and he has served in the program committee of a great number of international conferences about education, personalization, data mining, and artificial intelligence. In addition, he organized several editions of the EDM conference as program chair and conference chair. Finally, currently, he's associate editor of the IEEE Transaction on Learning Technologies Journal. His talk today is about educational data mining and learning analytics, an updated survey, which shows how educational data mining and learning analytics have been applied over educational data. We will see how this research area has evolved enormously, and we will understand better many of the terms related to this area. In addition, we will be updated about the current state of the art, key milestones, the knowledge discovery cycle, the main educational environments, the specific tools, the free available data sets, the most used methods, the main objectives, and the future trends in this research area. So thank you very much for being here in this edition of the HELMETO, Professor Romero. I give you the floor to you.
Okay, let us start. Thank you for the introduction and good morning to everybody. I'm Cristóbal Romero from the University of Córdoba, and I'm also member not only from the Cadiz lab from the University of Córdoba, but I am also member of a new institute. There is a new institute, the DAXI, is Data Science and Computational Intelligence, that is start from 3 universities in Spain, Córdoba, Granada, and Jaén. It's a new institute, and I am a member of the new institute. Okay, this talk is about educational data mining and learning analytics, and the idea is to introduce this topic to everyone interested to research in the topic. This is my maybe 1, 2, 3, 4, 4, the 4 review that I have right. So this is a presentation about my last review or survey about this topic. So I have a lot of background about the topic, and I want to update the survey. So the idea is that a new reset can be today to the current state of the topic. Okay, let us start. This is the outline. The outline is very long. I will try to do it in about 50 minutes. Okay, I will try. And this is the main topic that I will speak. Okay, let's start with the introduction. The first thing is there is a lot of words. Educational data mining, learning analytics, but there are more and more words and names very, very, very related. So what do we call it? The first is statistics. Statistics, although we maybe that all that we do more of the time.
Ho scritto Paolini e non c'è.
There is one. No, there is no question or something.
Please,
the question, please, at the end. Okay.
Can you close the microphone if you are not talking? Just Cristobal should talk. Please close your microphone. Excuse me, Cristobal, please, you can continue.
Okay. So the first and more related topics in this area is statistic. Okay, it's the order, the mathematics and the statistics. Years ago, they started machine learning. In 18, there is a lot of people working in machine learning. Then this la moda, no, is the name, no, is a word with a lot of people use. Years ago, they started data mining. Okay, with data mining, yes, with data mining appear new algorithms. For example, algorithm decision tree, association rules, specific algorithm about data mining that are really, really different from a statistic. Okay, years ago they changed the word to knowledge discovery in data. Currently, or some years ago, business analytic. Currently, a lot of research use data science. Other people speak about data analytic. A lot of people and enterprise love the word big data. All the people, big data, big data, big data. But all these are the same core idea. That is the same dog with different color. That is finding useful pattern in data. We want to find information in our data with different emphasis. But the idea in all these different research topics are the same. I love, oh, well, I don't know why, I love this quote. In this quote of William Edward Deming, say that in good, oh, I don't know what happened with the, I tried to start again here. Now, the quote is, in God we trust, all the other must bring data. So this is the importance of data, okay? In EDM, the development of e-learning and web-based educational system has been rising exponentially in the recent years. So the system produces a lot of information, a lot of highly educational value, but normally it can be so abundant, or we don't know how to use, that it's impossible to analyze manually one normal structure. So it is necessary tools that automatically analyze this king of data for structure, for institution, and also for the student. In this line, educational institutions currently have noticed that they have information systems that store plenty of interesting information. This information can be useful to improve not only the dropout of the student or predict student performance, but also strategic planning of this institution. In this case, they also need tools to analyze that data to automatically are needed. This is an image in which I want to show that normally in educational data mining, we only use diff data, we say data, but there are a lot of information that normally we don't use and we have or we can acquire or capture from our student. So this is only one piece of the big iceberg of data that we can use in order to have the really big educational data mining. Let us start with the specific definition of some words or keywords. The more important for me is the educational data science. Educational data science topics is the more general. The more general, and it means that it only works with data gathered or captured from educational environments for solving educational problems. This definition is very similar than other that we are going to show or to see. So educational data science, of course, is a multidisciplinary domain. It mixes computer science, education, statistics, with several related communities. In this picture, we see that educational data science has several very big sub-areas. One of them is learning analytics, educational data mining. That is the main topic of this talk. But also there are other very related: systematic, institutional improvement, learner analytic, and personalization, that is only oriented to the student, and academic and institutional analytic, that is only oriented to the academic part. What is now EDM? The topic, educational data mining. Educational data mining.
Sì, mi dica. Mio figlio è appena sceso, aspettate i chiari.
Ah, ok, sì.
Non ha capito di portare subito.
Background. Okay, EDM is the application of data mining technique to educational environment. As you see, the definition is very similar than educational data science. It's the same. But I want to show the process. This is the process in which we mix data mining, the process of data mining, with educational. In education, when we do research in education, we normally do the next process about hypothesis, testing, refinement. So when we mix the two processes, we obtain this picture. That is, we have an educational environment in which we can formulate an hypothesis. For example, I think that if I use my system or my methodology, the student learn or the instructor improve better, or the student obtain better score. This is my hypothesis. I'm going to test. Okay, in order to test, I need to obtain data, normally raw data, directly from sensor, from file, Excel file, etc. etc. I need to pre-process all the data. This is very important, and modify in order to obtain data prepared to can apply data mining algorithms. And to test, we are doing now testing if in order to obtain model or pattern that can an instructor or an expert in data mining interpret and evaluate in order to see if the hypothesis fulfill or not. Okay, you can see if really your student improve or your student fail or not. And you can, using the model, and if the model are interpretable, you can obtain the information provided by the model to refine your system, to refine your hypothesis, or to change your hypothesis. Oh, no, with my methodology, all the student fail. So this is very bad methodology. You have to use another. Oh, improve, but not all that I want. So you can change something and repeat in the next years, in the next academic course. Again, obtain data, pre-process, apply data mining, obtain result, see the model, interpret the model, see if your hypothesis is okay or not, and modify something in your system and your model, and again. So this is a cycle, okay? This is a cycle of improvement. Educational data mining is a multidisciplinary domain. Normally, it's an extension of three very important domains: computer science, education, and statistics. In fact, this is an old picture in which I try to define the difference between educational data mining and learning analytics, but it's very, very difficult. In fact, are mixes. Educational data mining normally apply more computer science that come from computer science and data mining. For example, I computer science that work in data mining. I use normally the word educational data mining. And learning analytics is the same, but they normally use other people that come from education, psychology, statistics, but both are the intersection of computer science, education, and statistics. When you mix, for example, computer science with statistics, it appears data mining, machine learning. If you mix computer science and education, you obtain computer-based education. If you mix education with statistics, it appears only a portion of learning analytics, because learning analytics is not only education and statistics, because learning analytics also use data mining. So educational data mining can be the core, but learning analytics is a little bigger, it's a little more general. Other related areas with EDN are, the first one is learning analytics, of course. Learning analytics, the definition is the measurement, collection, analysis, and reporting of data about learned and their contents for purpose of understanding and optimizing learning and the environment in which occur. So this is a very long sentence, but it's the same than the definition of EDN. It's applying algorithms to educational data in order to resolve educational problems. So practically it's the same. Another different topic is academic analytics, and also is very, very important, because academic analytics is the business analytics applied to education. And when the government of all the world notice what is really EDN and learning analytics, they say, oh, business analytics with education, I obtain money, or I can reduce funding, I can reduce money. Wow, they open their eyes and say, I want EDN, I want learning analytics, because this business intelligence applied to institutional academic data. Currently, only some private business, private enterprise are interested in this. For example, Santillana and some other big enterprise, but no public governments are currently. Only USA government are a little interested in academic analytics. But I see a very important research line and very important, more research line, no, more business line. And finally, another important topic is teacher analytics. This is another vision. In teacher analytics is when we use the instructor or teacher data. Yes, in this, the objective is to improve teacher, to improve the teacher, to detect the good and the bad teacher. Okay, to obtain data from the teacher. So there are a lot of, wow, when people see this topic, teacher analytics, Cristobal, all the people say to Cristobal, oh, Cristobal, this is when you throw a stone in your own house, no? Because this can, the computer can't replace the machine. So we are trying to monitor his teacher, to detect bad teacher, and try to replace with machine. So this is a topic with some normally create a lot of, not confusion, but expectation. Okay, let's see a lot of the evolution of the two related topic that EDN and learning analytics. If we see the number of papers published in Google Scholar, okay, this is from 2017. This is wrong. This is wrong. This date. Okay, is we see the number of papers in order to see how the both community have grown in the time. We can see that EDN in red start is older, and we can see that the first workshop started in 2006. The first book that I published, the first book in the end, in 2007. In 2008, the first conference in Montreal, the first handbook of EDN in 2010. Okay, I also published the handbook, and there is a change. The LAC conference, the Learning Analytics Conference, started in 2011, and there is a change in the attendance of the number of papers. You can see that the blue line increase like an logarithmic, no, exponential, no. And this community grow faster. The first Summer Institute, another very related conference is the Learning at Bit Scale Conference, and also appear the Handbook of Learning Analytics. So this community is also growing, ADN is growing, but not at the same speed than Learning Analytics. Learning Analytics had a bigger community, because the Learning Analytics community, there are a lot of, I say later, psychology, educational, a lot of people that are interested in this topic work in Learning Analytics. But educational data mining community is a little more closet community, because it's my data miner, my computer science core are more interesting in the algorithms, in the accuracy, in improve the algorithm, and no, for example, only the data, for example, only the application, okay, only the intervention that are very important. But in educational data mining, we are only focused in the algorithm, so it's a more closet community. Okay, let's see now the process and actor, the main process and actor. This is the main picture of the life cycle of educational data science in general. Okay, in this picture we see in this side we see the instructor and the academic authority. Okay, the universities and the culture are the person that produce the environment. Okay, produce the educational environment. The educational environment can be traditional, university, college, preschool, or also can be online. Online, Moodle, or Ilias, Blackboard, Cloud9, and also MOOC, no, the massive courses, Coursera, EDX, Udacity, okay? These systems, traditional, online, Blender, Smart environment, can produce when they are used by the student in the other side of the screen. The student interact with this system. When the student interact with the environment, produce educational data. These data are stored normally in that database. Raw data. If you use all this data, we can obtain information or new knowledge. How? This is the educational data mining or learning analytic process. This process consists of, first, data preprocessing in order to prepare the data, modify the data, to can be applied to the data mining or the method that you want to use. Then you apply the methods. We are going later to speed up about the methods. And the method produce models, results. This model, have to be interpreted and applied. The interpretation can be done by the instructor academy, and the application can be applied over the student of the system. So this method generate or produce knowledge. This new knowledge can be used by, on the one hand, by the instructor or academic in order to improve the educational environment, okay, and also modify in order to produce new data, but also can be applied directly in recommendation to the student, for example. If they have some problem with a student that is going to drop out, we can provide help. Okay, we can apply also in recommendation directly over the student, but also we can, the model can be recommended to the structure and academic authority to modify and to improve the educational environment, to modify the courses. Okay, this is the general life cycle, the process. Okay, let's see now the different goals. Okay, this knowledge that can be discovered from the educational data is very diverse. Yes. And also the main objective depend on which, for example, depend who is the final person interested in it. Who is addressed the knowledge? The knowledge, who is the student, the teacher, or for example, the academic authority. Or for example, what kind of information or what type of information is available? You have the information a priori, you have the information a posteriori, you have to, from the first day, you can obtain data, you have to wait until the end of the course. Also, what is our environment on internet? Traditional learning, distant learning, web-based learning, blended learning, etc, etc. So, is our goal are the student, for example, for a student perspective, what learning analytics or educational data mining can provide to the student. And a student can say, okay, for me, what is this good for me? For example, from a perspective from the student, we try, for example, which activity or resources, tasks could improve the academic performance of the student. We can detect using information from past students to see, oh, this type of information is good for this type of student. This activity is good for low-level student. This, okay? For example, which activity are the most suited to give a student or knowledge to a specific profile? Or for example, which path or which route should a student have or travel during the course to obtain a specific result? For example, in a university, you can select some subject or some courses that are not mandatory, and you can select. So we can recommend the travel. No? We can recommend to the student. For example, based on previous knowledge, on the past already traveled by previous student, similar than this current student, or comparing the path by other students with similar profile. Okay, this is from the student perspective. From the professor or instructor perspective, is the more studied topic. This is the most studied. From my opinion, I am working in this topic a lot. No, professor perspective. That is to quantify the effectivity of a learning process, to organize the content of a given course, to improve or review the structure of the course, to evaluate the activity performance in a course, performance, motivation, to monitor the activity, to find the most common error in the development activity, to set the level of an activity, to personalize and adapt the content of a course, designing to plan, to classify or cluster students from the features, mentoring, assignment, monitoring interest knowledge, also to find behavior pattern in students, general pattern, rate pattern, etc, etc, etc. Okay, from the professor perspective, it's a lot of hot topic. And also there's the institutional, oh, excuse me, or the institutional or academic perspective. From this view, we can improve the efficiency of, for example, the website or the environment, and adapt to the user behavior. For example, you can have a lot of students, only a few or few students, and they use some tasks and other, and they use the forum or they don't forum. So we can design the optimal web survey, and we can optimize the network traffic distribution. We can optimize a lot of things. If we try to monitor it, the log file, for example. Also to organize the institutional resource, yes, the timetable, the courses, the planning acquisition, and also to improve the academic offer, yes, the academic offer of one university or one country. Yes, what are the most demand-oriented programs? What are the new topic of interest to the student? Also grouping a student according their objectives, their capability. So there is a lot of things that we can do about institutional perspective. This topic is the less investigate, the less paper. There are only a few papers about this, but I see a lot of increasing in this topic because there are a lot of money, okay? Because it's a business perspective of the educational data mining and learning analytic topic. Okay, let's see now to the most important part of this. That is data. Okay, I need data. We need data. I need more data. Good data. We need good data. Okay. In educational environment, there are different types, okay? So data are different depending of the educational environment. In general, I try to group in this figure traditional face-to-face learning and also e-learning, computer-based learning, all mixing in the new blended learning. Blended learning now is a hot topic, no? Because mix the traditional face-to-face with the online or computer-based learning. E-learning is the most general. In e-learning, we mix computer-based learning with online learning, web-based learning, internet-based learning. The definition of these are very interconnected, you know? Okay. But for us, characteristic of the data, this is the really important. Okay. The first thing that we have to know is that information comes from different sources. Okay, we will have different sources of data. I'm going to stop the icon dictionary. Wow, my throat is. There are a lot of incomplete and lost data. Normally in a student, because not all students carry out all the activity. There are a lot of incomplete and lost information in educational, okay? It's very important that this information is, we have to fulfill, we have to try to resolve this problem. The next, user and student are clearly identified. In educational, we have the student perfectly identified. We only need to anonymize, okay? The student, we know who is the student, who student use the login and password in Moodle, who student go to the traditional classes in person, we have the final exam, we have perfectly identified. We only need to anonymize, okay, in order to protect the identity of the data. Next, there is a great number of available instance and attribute, a lot of, that recreate tasks of filtering and selecting what are the most important for our hypothesis, for our objective. So we don't need to use all the attribute, all the data that we have normally. Depending on what we want to obtain, we will have to use the good data. Next, educational data have different level of granularity. Yes, low level, for example, have a log file, all the events when the student enter in Moodle. And high level, for example, I have a level activity, activity or level. Higher level can be, for example, a course level, what courses the student have doing in one university course. Okay, we can increase the level or download the level. More data or more quantity of data or lower quantity of data. And also, we need some transformation, some automatic algorithms. For example, discretization is very useful. Why discretization is very useful? Because it's more comprehensible. Its data are discrete, categorical, no numerical. For an instructor, we see, oh, if the student send more than 5 email, wow. It is better to say, if the student send low, medium, or high number of messages, so it is more comprehensible and useful in order to obtain better comprehensible using model than numerical models that are more accuracy but are not so accuracy. The tasks. We have two types of tasks, low-level tasks and high-level tasks. Okay, low-level tasks are the general data mining tasks, okay? They are the normal, we are going now to explain this, are the traditional machine learning and data mining tasks, okay? They use, they are similar, but the knowledge are really the same tasks. The only difference is that we use educational data, but it's the same, the machine learning data mining. The high-level tasks are specific in EDN and learning analytics, and they try to solve a specific problem in the educational contents. So, normally they involve one or several low-level tasks, and also the interpretation is different because it's specific to education. So, let's see these low-level tasks and then the high-level tasks. Low-level tasks. The low-level tasks can be grouped in two main categories, predictive tasks and descriptive tasks. Predictive tasks are supervised. Normally, predictive tasks are supervised, in which the output information is available. For example, normally, these two types of tasks are classification and regression. In classification, you want to classify a student, okay, in classes, but you have a priori the final class. And regression, regression is similar than classification, okay? It's similar, but in classification, you have a class, and in regression, you have a number, okay? Descriptive tasks. In descriptive tasks, they are unsupervised. That is, the output information is not available. They are very useful because you don't need to wait to have the final class. Examples are association and clustering. In association, you obtain rules, you obtain association between data. And in clustering, you describe group of students, okay? These tasks are traditional data mining and learning analytic, machine learning tasks. In all the books about data mining and machine learning, you can read about all the algorithms about classification, regression, association, and clustering. When you use data about education, you can apply all these tasks in general without problem. You can use, okay, because they are low-level tasks. But if you miss some of them to resolve one specific problem, then you have higher level tasks. A higher level task, in this case, is when you try to really resolve a specific problem from the educational area. Here, I show a list of some. There are some of the problems that I detect that are more papers have published, but there are a lot and a lot more problems in educational data mining and learning analytics. Some of them are this. For example, analysis of the data in general. That is a statistic. When I speak about analysis, is a statistic. Sometimes you don't need to apply data mining. Only the media or only a quick analysis show what happened in your class. For example, you have 10 students, only 10, and all 5. You don't need to do nothing. This is a disaster. You don't need to apply data mining. No. Only a basic statistic show you that all your students 5. This is a quick analysis. Of course, if you have more data, 1,000, 100, 1 million, you need visualization. You can visualize your data, the media, the more frequent, and you can see what happened in your class. You can see faster what happened. Or most of the student file pass, what type of student file. Visualization is very useful to the instructor in order to see quickly what happened. And later you apply more advanced algorithm, more specific data mining algorithms. Next task, providing feedback. Providing feedback normally is to the instructor. Okay, when you provide feedback, you use several predictive algorithms, clustering also, and the objective is to provide useful information to the instructor in order to improve the course, in order to show what happened in the course and try to solve the problem. Recommendation normally is to provide information to the student, to recommend to the student, to recommend what to do next, to recommend what course they have to do, to recommend what tasks they have to do. This is recommendation. For example, another very important task is predicting performance, predicting student performance, predicting academic performance. It's it's the older task, okay? I work a lot in this task. I am an expert in this task, okay? Because it is one of the most important, because if you want to provide help to a student, the first thing that you have to do is to say, okay, detect what happened with the student, to detect the score, to detect the performance, and to classify. Good student don't need help. Bad student or a student with a file with low performance need help. So you need to predict performance, and later you provide or not help. So predicting performance is the older task in EDN and is very important. Another very important task is student modeling. Student modeling, try to model the student in the machine. Vale? Intelligent tutoring system, use this. Personalization, use this. Okay? Detecting behavior is also very important. Detecting behavior, good behavior now, rare behavior. Rare behavior, strange behavior, bad behavior, a student that try to hack the system, to do bad thing, no, with the course, no, plagiarism and songs like this. Grouping a student, to automatically group a student by performance, for example, okay, by profile, a student that are active, a student that are low active. For example, in MOOC, use a lot of grouping a student in order to provide adapting the system to this type of student. A student that are very active are faster student, you provide more information. A student that have some type of problem, a low speed student, you provide less information or adapt information to this type of student. Social network analysis is a new topic also, that try to analyze a student, but see a student as a social network, because students communicate between them. Yeah, they communicate using email, using forum, using chat, okay? Another thing is developing concept map. Concept map are also very useful when you try to automatically, for example, use Courseware. Courseware, we try to automatically create new courses. Yes, constructing course quality and to modify course and to provide new information and to concept map are useful. Planning and scheduling. Planning and scheduling is about academic analytic. Planning the optimized courses and scheduling in which order are the course or the subject better for the student. And finally, I mix concept mapping with constructing course quality. Constructing course quality when we try to automatically, the machine try to automatically create new courses, okay? Using other courses from internet and from past courses from you. You automatically can create new courses. And this is a graph on the papers published years ago about this category. But this is a group of some tasks that I detect some years ago, but there are more and more. So they are not the only one. There are much more tasks and topics, okay? Next, resources. Okay. Now we need to, there are a lot of resources available. Wow. For example, what are useful resources for you? If you are interested in this topic, the first thing, or what are the main web page that you have to visit? The main is this, Educational Data Mining Society. In this web page, that is this, you have information about the society in which there are all the conference. This is the annual conference. This year, Educational Data Mining Conference, the past year was in Paris, okay? It's in Paris. And the next year will be in UK, okay? United Kingdom. And also have about the Journal of Educational Data Mining, okay? This is a specific journal that I also recommend to read by all the person interested in the topic. The broader community is Society of Learning Analytics, the solar community, in which you have also the same. You have the conference, you have the journal of Learning Analytics, but also there are more conference. They are the summer, okay? They are the summer conference. And also recommend this, and this is the link, okay? More. There are more courses. Introduction to the topic, yes. Similar, for example, than this talk. My talk is only about 51 hours. Wow, I have to finish. Wow. I use the 50 minutes. I have now to run out. Okay, Big Data in Education is the MOOC course that Reinbacher, okay, was the first MOOC. This is the MOOC, okay, years ago, more than 10 years ago, but I think that Ryan Baker will do again. Another MOOC that you can do if they start again is this from EDX, Data Analytics and Learning Analytics MOOC. I recommend also. Now, the PCLC Data Shop. This is the bigger data repository with educational data mining. But the only problem is that only about intelligent tutoring system. Intelligent tutoring system is specific, okay, about mathematics, social, English in USA, okay? So this is no traditional education, this is no Moodle. It's only intelligent tutoring system, okay? But they are free available data. You have to create an account and you can download the data and reset, okay? This is using the UC repository. There are some data set. This is the most popular, the student performance data set, but there are some other. There are some other free data set from download free. Okay, software that you can download and use. For example, the general software are the most popular Weka. I recommend Weka. Normally I use Weka, but some other person want to use RapidMiner. is also in Java. And if you are a programmer, you can also use R, okay? R and Python, okay? R and Python is a programming language that have a lot of library. There are a lot of specific software, yes, but the problem is that the specific software only work with the specific data, and also they are not free available. This is a list of a lot of specific tools that you can use, but you have to request to the author and you have to request also the data. So it is a pity, but I don't recommend this. If you use Moodle, yes, they are free educational data mining data set. No, Moodle and other, okay, they are general, free educational. This is very important, okay? This slide for me is the one of the most important because data is the goal, but it's the more important. So you have free dataset, Canvas network dataset. It's a MOOC, it's very big. Data shop is the previous one I showed you. Another MOOC from Moodle, MOOC EDA datasec. This is Open University Analytic Dataset is also very, very good, this dataset. And Student Performance Dataset is the previous one, okay? But in this slide, you can download free dataset that you can today start to reset, to work, okay? You don't have to do nothing. You don't have to acquire your data from your student. They are free, available. They are anonymized. You can go to the web page, download to your computer and start to apply your algorithm or Weka or RapidMiner or R or Python. And in order to finalize, then, what are the trends and future lines that I see and I detect in this community? Okay. Ryan Baker, some years ago, in the conference in the Learning Analytics, proposed a Learning Analytics Prize, in which he proposed some most important research topics are challenges in the area of EDM and Learning Analytics. And they are these. The first one was transferability of model. Transferability is when, if you obtain a model that predicts student from your course, for example, my course is the first degree in computer science in Córdoba. How is the transferability of the model, my model, to other courses from the same teacher or other teacher, other university? So can I, my model, apply or transfer my model to other professors that use the model effectiveness to improve the effectiveness of the prediction, the effectivity of the model? Another hot topic is the interpretability. It's very important, the interpretability of the model. We need modelo de caja blanca, white model, no black model. Black model, no. For example, deep learning are very accuracy, are very good, a good effectivity, a good accuracy. But the learning provide black model. They are not clear for the student to interpret the result. They don't provide information about why you have classified the student. You classify the student very good accuracy. Yes, 19% accuracy, very good. But why you are classifying my student good or bad? In order that I provide some help. So we need interpretable model. We need decision tree model. We need rules. We need white model. Next, the applicability. Of course, the model can be easily applicability. For example, deep learning are very difficult applicability. They need to train and modify few parameters and then apply. If you have to apply to another, wow, you have to test your model again. So the applicability is very also important. And finally, the generability. The generability is the most hot topic, not hot topic, difficult topic. Your model or your result ideally can to be generalizable to other courses. It's very difficult, of course, because normally when you obtain a result, your result, the ideal is can be generalizable or generalizability to other courses, to other university, but normally not. So the generalizability is very important. Okay, there are these 5 important topic challenges, but in my opinion, finally, my opinion, I propose other more visionary ideas and also more related with the data. Okay, my personal ideas, my personal visionary idea of the future of EDN learning analytics. I see 3. The first one, okay, the first one. Instead of when you do or you apply educational data mining analytics, you use only one type of data, your data. My data of my course, my data that I downloaded from internet, my data from my students or from Moodle, only my student Moodle, okay, they are my data, and I try to predict something. But in the future, I detect that we are in the area of the data. The data, we have information in computer of all our life. Yes, we have the information of our student from the hospital, from the kindergarten, from the school, from the other academic, from sport, from all the information of the student of all the world life. Yes, the world life. Your eyes are open, no? Privacy. Yes, we are getting data all the time. When we born in this life, in the life we born, we are monitored with machine. Yes, we are monitoring all the information and introducing computer. So we have all the information, all the student, all the personal data. Yes. So in the future, I detect that we can, in the future, we will can use all the personal information of the whole life of the student in order to predict better for each specific student what is the best for. Of course, we have the problem of privacy, but this is one of my visionary ideas. The second one, I don't say that it is good or bad. I say the visionarity. The second one, applying in the same line, applying and integrating EDN and learning analytics fusion data from multi-sources, multimodal, multi-source. We have data from several sources in one course. For example, my student, because the education has changed. We are now, years ago, we have only traditional education. The student, the teacher in person, one pen, the teacher speak, student write, traditional education. But currently, we are in the upcoming technological smart educational environment, full sensor, with cameras, with sensor monitoring student, her rate, all the. So in the future, in fact, currently, I obtain data from a student from different sources, from Moodle, from my exam, from writing, from the final exam, from the theoretical classes, from the practical classes, from programming, from forum, from email, and I integrate from video and integrate fusion all the information. In the future, we will have more and more. In this line, we will have really from a small course, for example, 10 students, a lot of data. Because if you have one student monitors it all the time during the one course, only 10 students generate huge tera information, terabyte information. Video, audio, text, all the students speak, all the students write, all the students see. What is the student see and smile? The emotion, yes, detect emotion, detect all the information, integrate all. So this is really, really big data with a small school, a small student, or very small. And finally, let's go another deeper. Okay. If we go more philosophically, okay, educational data mining, learning analytics. We try to resolve educational problem, but we need to detect with data if the student learn or not learn, or learn better or not learn better. So that is how to detect if a student learn. Normally with a questionnaire, with an exam, with activity, with participation, with the emotion. There are a lot of ways to try to detect or predict student performance. But really, when a student learn or when not in the brain. So if we can see the brain of the student, if I can see now currently your brain, and if I can see if you are now see to me and also are attention and now are learn or not. So in the future, I detect that we need to analyze a mini data directly gathered from the student brain. Yes, from the student brain, from better understanding of the learning in real time. Yes. In fact, in China, currently, yes, in China, in school, in primary, they use something like this. Mindways mobile. There is this is to monitorize the brain, the attention. Okay, you put it's similar than a microphone, but when you put this this in the ear, and this is in the front part of your brain, and you monitorize your level of attention. And in China, monitorize in real time during the classes with the student attend and what student don't attend. Okay, so this is a first step in order to monitorize the student. This is a wearable, is cheaper, and you can put one for each student in order to monitorize and acquire data directly from the brain to your database that you can integrate with your video, because you can see me, you can see my slide, your eyes see me, but your brain can thinking another thing about your girlfriend, about your party. So you see me, yes, but you brain and attention me, yes. So maybe that you are learning. Okay, so this is them, and this is thank you, and there are some questions. And if you want more info about this topic, this talk, all these slides are based in this paper. This is a paper. This is the title of the paper. This is the web. Okay, I sent to Pietro the PDF of the paper in order to share with all of you. Okay, so you can obtain more information. And only, wow, I pass 5 minutes. If you have some question, I don't know if I have time for
Thank
questions.
you.
Yes, thank you.
Sorry, but when I speak, I lost the notion of the time.
Don't worry, this was a very interesting talk, so we don't mind that you pass 5 minutes. Thank you very much for this talk, and yes, we have some minutes for questions. Then please go with the button of the hand raise, and we will give you the floor. In the meantime, I would like to ask you something. Just is a curiosity because I was really surprised when you explained that academic analytics are just used in the United States. Why do you think that this happened? Don't you think that Spanish or Italian or European universities or enterprises didn't realize the potential of this data, or what do you think is the explanation?
The explanation is very simple. In Europe, it's a pity. It's a pity. We are all the time late, all the time in all things. This is similar than la moda, no? La moda. The moda start in USA and they go to other part of the world. So this is a pity, but it's true. In fact, Obama request some years ago. Obama passed years ago a request to Ryan Baker to write a survey review about what are the potential of learning analytics, educational data mining to improve academic analytics. Also student analytics, but teacher analytics, but wow, academic analytics. Because wow, if you have a lot of academic, a lot of university, a lot of, and you optimize, they optimize price, thinking that one instructor, from this point of view, we are a peon, no? So maybe that we don't need you, or we don't need you master, or we don't need because we can fuse your call with the other or with other university, or we can reduce the number of university. This is very dangerous for us. We can be dangerous for the university. Because if this information is used by bad governor or bad job, do you understand me?
Yeah.
We are in dangerous, the structure really, and the university. Because they can see us as a business, not a service, a mandatory service for the humanity. For example, for medicine, education is a pillar. So we are not a business. But when you try to see this as America, in America and USA, medicine is private. Education is similar. Not all the people studying in university in USA, only people that have money. Here in Spain, we are, so they are much more interested than us because they really optimize. Okay, so I know that there are institutions interested in this. I know that in Spain and also in the community European, but they are slowly. And I hope that they are slowly, because we are not prepared on this. We are not prepared. And this can be dangerous because this can be to put a gun to a monkey. Do you understand me? If you this tool to for example to the community European, and they say, okay, we are going to reduce a lot of money. We have to reduce universities in all Europe, applying an algorithm to reduce, and they also apply. No. So this can be, but we need to do very slowly. Do you understand? No? Currently, I detect that only business, private enterprise, private business. For example, Santillana. Do you know Santillana? It's very big in Spain and in Latin America. Coursera, EDS. What is the other? There are some private in educational business that they are very interesting in offering the academic analytic. In the public is currently is a little more here in Spain. There no, okay.
Yeah, but we could see like a way to reach a wider target, not as a way to delete or to remove teachers, right? It could be focused in a positive way, right?
Yeah. The future. Okay, I'm going to show you. I don't know if you can see this or no. You can see no. I tried. You can see the book.
Yes.
You can read the title.
No.
No. Oh. No. Oh. Okay. No. I'm going to. I share. This is my last. Wow. It's philosophy of of the educational data mining. Robot replace teacher. Is the more heavy this okay, this book. It's from USA. It's very this is the book. You can see now?
Yes.
Wow, it's incredible. I read the book and it's the future, really future of the at the last time apply educational data mining, learning analytics to not to can robot replace? No. Yes, they can, but they should. Do you understand?
Mm-hmm.
They can, but they should. The answer is not, of course.
I agree.
But not to a normal or good teacher. But yes, for bad teacher. They are yes, they are bad teacher. They are teachers so bad that a machine do better. So we can detect teacher bad, yes, maybe that we can detect a bad teacher. There are no few bad teacher. There are only a very few bad teacher. But sometimes bad teacher can be replaced by other teacher, by the machine. Do you understand? But of course, never, and I say never, one robot win to a good teacher. That is similar than when Gary Kasparov, a machine did blue beat to a guy Kasparov. I think that the blue win Kasparov playing chess. Okay, but in educational, a machine never win to a normal teacher. Yes, maybe bad teacher, of course, but to a good teacher, never. So if you are a good teacher, don't worry, never a machine will replace you.
Okay, thank you very much, Cristobal. We have another question from Matza Ricardo. Please.
Hola, Cristobal. I have a question for you. I used to do learning analytics already in 2004, visualizing some data from learning management system, but I suddenly had to give up because lack of data. And currently, before the COVID, the use of educational technology were mostly, 99% of the cases, access to PDF, some discussion, maybe some quizzes, and that's it. Yeah. So I always have this doubts in learning analytics that the good data, so the data that allows you to give good estimation or analytics lacks. So the except some cases where university, like your university, Open University, do a lot of interaction. In the vast majority of cases, university has no data to perform an analytics that give you a real added value. So what is your point, or opinion in this aspect?
Okay. I try to think about the exact question, but for example, you have speak about with the COVID, for example, in order to obtain really good data, when you, for example, during the COVID, I use it also, but of course, a student had to sign to provide permission, had to record also the video, the audio from their home. Also, my student, when we start the course, the first thing that I do is, okay, you have to sign providing me permission to display all your data or to record your screen. Yes, for your computer science. You record your audio and all the data I will use. I will use in my research, and also I will use to predict your final score. Okay? So I think that your question is about this, no? If you obtain more data in order to the prediction that I try to do in this, for example, is to predict as soon as possible, good and bad student or student with problem. So with the new technology, we have a lot of research or sensor to obtain data in the first week to detect more participate, more engagement students that finally are the better student to, for example, for prediction. But I don't know, is your question about this or is your question about the academic point of view of the obtaining the data? Can you specify more the question about what is my opinion about the obtaining of the data, or what is your
it's
question?
simply that with the data that is currently available, for instance, in my university with the Moodle platform, I think it is too poor as
yes, of course.
Yes.
Thinking. It's okay. I do this test. With only Moodle data, the best result that I obtain are about 70%. If you add to the Moodle data more information, for example, from traditional practice, or for example, from external works, for example, videos, for example, more exam, middle exam at the middle of your course, not the final exam that is the prediction. No. If you with you more data, multi-source, but depend of your type of course. It's the problem. Depend of your course, depend how you impart your class, can be better some type of data. Of course, with more data, you improve a little, but maybe better visual data, audio data. But this is in which currently I'm working. I am working in order to test to what problem, what are the best data and no data, attribute. What attribute are the better for your problem? And then how I can acquire the attribute. But normally, professor work or instructor or researcher in this area, we work in the opposite way. We have data, and for example, Moodle data, and then say, I want to resolve the problem. So I don't resolve the problem. No. What is your problem? Your problem, you need the data. Obtain the data. So you need 1 year, 2 years preparing, obtaining data. And then very fast apply the algorithm. Do you understand? So the most important are data. For me, is the goal data. So the most important is to define which data and attribute resolve your problem. Then how I obtain the data? Moodle, camera, videos, audio, acquire the data 1 year, and then apply the algorithm. Okay?
Thank you, Professor Romero. Please continue discussing the coffee break to avoid overload the other sessions. Thank you very much for this very interesting talk.